Happy Monday. Here's a cute picture of Casey Joe and Cody Ty just to cheer you up on this Monday morning. I thought it was pretty cute because I caught him smiling. Alright, go ahead and get out your notes. Today's lesson is 1.5 Inverses of Functions. So we talked about inverses in Algebra 1, but it's been a while, so we're going to go ahead and go over it again. Take a couple of seconds to finish writing that down. And then turn to your notes page. Alright, so if you would recall from Algebra 1, the inverse of a relation is formed by switching the two variables. And if we're dealing with functions, our variables are going to be x and y. So we are given a function here, which I'm highlighting in pink. And we're going to list out the coordinates. So I'm going to start here at this first point and then work left to right. So this first one is at -2, +1. And then -1, +2. 0, 3, 1, 4, 4, 5, and then 7, 6. So those are the 6 coordinates of this function. Now we're going to find the inverse of this function. So remember, inverse is just like opposite, okay? Like the inverse of multiplying is dividing. The inverse of adding is subtracting. So we're going to find the inverse of this function by switching the x and the y variables. So let me find a different color here. And we're just going to switch them. So I'm just going to switch the spots of the x and the y. So -2, 1 becomes 1, -2. And then the next coordinates would become 2, -1, 3, 0, 4, 1, 5, 4, and 6, 7. So now that we've switched the coordinates, let's go ahead and graph this new function. And you should get something that looks like this. So, a function and its inverse also reflect over the line y equals x. Let me show you what I mean. So here's my line y equals x. It's just where every coordinate equals, so like 1, 1, 2, 2, 3, 3, the x and the y equal the same thing. So here's the line of symmetry that this function and its inverse reflect over. Anytime you graph a function and then you find its inverse, they both should always reflect over this line y equals x. Okay, we can also notate a function by this symbol f to the -1. So anytime you raise something to the -1, that means the inverse of it. You could also have like g to the -1 or h to the -1. Anytime you raise something to the -1, that means the inverse. Alright, so now let's look down here. On each graph, we're going to sketch the inverse of the relation. So let's start off with number 1. Let's just find a couple of points that would be easy to plot. So here's one at negative 4, 4. And then one at negative 3, 1. Negative 2, 0. And then I'm just going to find the opposite sides. Alright, so if you need to, you can go ahead and list out these points. You don't have to if you don't need to, but it is going to help. So let's start over here on this most far left one. This is at negative 4, 4. And then this point's at negative 3, 1. Then negative 2, 0. Negative 1. Positive 1. And then 0, 4. So now to find the inverse, all I need to do is flip these coordinates. So let's start with the negative 4, positive 4. So I'm going to flip-flop them. So now I'm going to put a point at 4, negative 4. And then now let's switch the negative 3, 1. So I'd be at 1, negative 3. And then 0, negative 2. 1, negative 1. And 4, 0. So you can see we get the inverse. It has the exact same shape and size, but it's just been like rotated over. It's reflecting across this line, y equals x. Okay, now let's do the next one. So pick a couple of exact points on the original. This first point would be at negative 5, 0. Then we have one at 0, 1. And 2, 4. Now to find the inverse, we're going to switch these coordinates. So I'm going to switch negative 5, 0 to 0, negative 5. And then 1, 0. And then 4, 2. Whoops. There we go. So once again, you can see that perfect reflectional symmetry about the line y equals x. Okay, moving on to number 3. This one's a little bit harder. So here's an exact point down here. Then I've got another one here. I'm just going to pick about 4. Okay, I want you to try this one on your own for a ticket. So you're going to find some of these coordinates, switch them, and then graph the inverse. If you get it somewhat relatively right, you can get a ticket. Alright, so let's see how you did. This first point is at negative 5, 5. And then negative 4. Oh, this was negative 5, negative 5. My bad. Negative 4, negative 1. Negative 2, positive 1. And then 0, 3. Like I said, you don't have to write those out, but it does help you. So negative 5 is going to stay the same. And then I would graph a point at 1, negative 2. And then negative 1, negative 4. And 3, 0. This one's a little bit harder to graph. You could get a little bit more exact if you got some more points there, but anyways, it should look something kind of like that. So if you got remotely close to that, you can get a ticket for your effort. Good job. Okay, moving on to number 4. So pick some points. You can just do this one with me. I'm not going to write out the coordinates this time. So I have one point up here at positive 1, 5. So if I flip it, it would be at 5, 1. Then my next coordinate's at 2, 2, so that's actually going to stay the same. Then I've got this vertex at 3, negative 1. So if I switch it, it'd become negative 1, 3. And then I've got this point at 4, 2. So it'd become 2, 4. And then 5, 5, so it's going to stay the same. And there you go. So even though it looks crazy, let me outline this one in blue. You still can see that it has this perfect symmetry going through that line y equals x. Alright, so now that we've found the inverses of all of these graphs, let's talk about which of the original relations are functions. How do you know? So remember, an easy way to tell if something is a function is by doing the vertical line test. So out of the original functions, which are all in blue, they would all pass the vertical line test. None of the x's repeat, so it would be a function. So then it says, which of the relations have inverses that are functions? How do you know? So now we're looking at the pink ones that we drew. So out of those, which ones would pass the vertical line test? Well, this first one definitely wouldn't. If I drew a dashed line down here, it has more than one x that would repeat. So that one is not a function. Okay, number 2, that one actually is. Even though right here it looks like it wouldn't pass, it is, because it's just getting really, really, really close to this line. So it's still decreasing, but it's not a perfectly straight line. Okay, number 3 looks good, but number 4 would not. If I took a vertical line, it would go through more than one x on that graph. So the only 2 inverses that are functions would be number 2 and 3. Because numbers 1 and 4 do not pass the vertical line test, which I'm abbreviating VLT. So whenever a function and its inverses are both functions, it's called invertible. Meaning that its inverse is also a function if it passes the vertical and horizontal line test. So let me explain what I mean by that. So if something originally, let's just take a parabola, looks like this, it passes the vertical line test, but if I invert it, it's going to turn and look something like this, which would not pass the vertical line test. Because if you take a vertical line and invert it, it becomes a horizontal line. So for something to be invertible, it has to originally pass the vertical and horizontal line test. Alright, let's move to the next page. So here's some Excel examples from what y'all are going to be doing. It says the function f of x is invertible. Find f inverse of negative 20. So we're going to find the inverse of negative 20. Okay, remember that normally we have an x and a y. But whenever I take the inverse, I'm switching those. So if I'm looking for the inverse, I'm actually going to be starting with the y value. So I need to look at when my y is negative 20, what is my x? So my answer would be negative 2. So I'm not really looking for the input, I'm looking for the output. Same thing over here. The function f of x is invertible. Find the inverse of f of 0. So really, this is when my y equals 0, which would give me an x value of negative 2. Okay, now let's look at these on the graph. So I need to find the inverse of negative 4. So instead of looking at when my x is negative 4, I'm looking at when my y is negative 4. So I'm going to go to my graph, go down here to when my y is negative 4, and I can see that my x would be positive 2, because this is at the coordinate 2, negative 4. So my answer would be 2. And that's it. Alright, if y'all have any questions, let me know. Hope you have a great day.